In our last video, we talked about how absolute value is the distance from 0, but what we talked about was when we had an equal sign. Now we're going to have an inequality. We're still talking about the distance from 0, though. So if we're looking at this one, we are saying that x is compared to 3 away from 0, but instead of being exactly 3 away from 0, it's saying x is less than 3 away from 0. So it could be right here, it could be right here, it could be right here, it could be at 0, it could be over here, it could be over here. It's somewhere in between 3 and negative 3. And it's not including 3 and it's not including negative 3. Look at this picture. It looks like a compound inequality and statement. Now if we just look right here and ignore the left side, if we just look right here, we are actually talking about x being less than 3. And if we just look right here, we're talking about x being greater than negative 3. And if we look at the picture is an and statement. So we're going to say that x is less than 3 and x is greater than negative 3. And the graph goes as such, negative 3, 3 open circles, and they're connected because it's an and statement. And here would be our answer. Now that was a very simple problem because it was just x, absolute value of x is less than 3. I want to point out a couple things though. Notice right here, if I didn't have those absolute value signs, if I just had x is less than 3, I have that right there. Also notice that when I changed it to a negative 3 like we do with the absolute value, all of a sudden those signs have switched. Just like before when we multiplied or divided by a negative, we switch the sign. When we do our negative version of absolute value, we have to switch the sign. Now a lot of books are going to have you memorize this and or based on what this is. I'm not going to have you do that. Instead what we'll do is we'll solve a problem and we'll graph it and then we'll see, does it look like an and or does it look like an or? So let's look at this next one here. This is saying the distance is less than 4 away. So x minus 2 is going to be less than 4. And if we look at the number line, it's going to be less than 4 because it's less than 4 away. And when we look at negative 4, it's going to be less than 4 away, but that's on the right, which means it's greater than. So x minus 2 is greater than negative 4. Again, when I do the negative version, I switch the sign. Now we're going to go ahead and solve both of these. So add 2 to both sides. X is less than 6. Go over here, add 2 to both sides. X is greater than negative 2. Now this might be an and, this might be an or, but in order to find out, we're going to graph this. Make sure you put your numbers on the right spot of the number line. Negative 2 is on the left, 6 is on the right. X is less than 6, that's an open circle to the left. X is greater than 2, that's an open circle to the right. And look at that, they're connected, so this is an and statement. Now look at all this, this is a big answer. I've got my two inequalities, I've got my and sign, and I've got my graph. Okay, let's look at this. Looks a little bit simple here. Let's talk about what it means. So this one's saying the distance is more than 3 away. So if I look at 0, I've got more than 3 away. It's going to go that way. And I've got more than 3 away, so it's got to go that way. So if I do this, I've got x is greater than 3, and I've got x is less than negative 3. Remember, I'm switching the sign when I do the negative version. Now if I look at the graph, that's an or statement. So here would be my answer. Of course, it's going to be way more complicated than that. Let's look at the next one. So here we have x is, or 3x minus 2, the absolute value of that is greater than or equal to 8. So we're talking about the distance being more than 8. So 3x minus 2 is greater than or equal to 8. And then on the negative version, it's going to be going to the left now, so I got to switch the sign. Go ahead and solve both of them. So I add 2. We've got 3x is greater than or equal to 10. Divide by 3. You guys, look at this. We've got a fraction. It happens. You got to be okay with that. Add 2 to both sides here. We've got 3x is less than or equal to negative 6. Divide by 3. X is less than or equal to negative 2. Now I've got my two inequalities. I need to figure out whether it's an and or. So I'm going to graph. Let's see. Negative 2 would go on the left. 10/3 would go on the right. X is greater than or equal to 10/3, so I fill that in, go to the right. X is less than or equal to negative 2, so I fill that in, go to the left. And if you look, they're going opposite directions. This is an or problem, and here's all of my answer here. Now for the fun part. I can't believe they have you do this, but the MCAs have you do a problem like this where you have to set this up. So let's see if we can understand this. A manufacturer has a 0.6 ounce tolerance for a bottle of salad dressing advertised as 16 ounces. What this means, people, is you have a bottle of salad dressing, it says it's 16 ounces on the label. Now, the machines don't always get exactly 16 ounces. So what the manufacturer is saying is it's okay to be 0.6 above, or it's okay to be 0.6 below. Meaning you could have a bottle that's 16.6 ounces, and that's okay with the manufacturer. Or you could have a bottle that's on the other side, and it's 15.4 ounces, and that's okay with the manufacturer. They're still going to advertise as 16 ounces. So we need to figure out what is the inequality of this. Now, let's ignore 0 for a second. We are centering around the number 16. We could be 0.6 above, and that would be okay. Or we could be 0.6 below, which would be 15.4, and that would be okay. So we have to somehow figure out how can I have this equation here be my answer. So I'm saying the distance of something. And look at the distance. What is this distance that we're talking about? We're talking about the distance being 0.6. So this distance is related to 0.6. So it's 0.6. The distance is actually less than 0.6 because we're going underneath it. So we're going less than or equal to 0.6. Now the distance of what? And when we're looking at that, we're saying, well, the actual bottle is X because we don't know what that is. And if we take and subtract 16 from it, remember 16 is that magic number, that's okay. If we take 16 away from it, we're either going to be above 16 or we're going to be below 16. And we're saying that that's okay to be within 0.6 or at 0.6. For example, let's say that the bottle was 16.2 ounces. That means if I take away 16 from that, I'm going to get 0.2. Now that's okay because that is less than or equal to 0.6. So when you're doing one of these problems, I know that might have seemed confusing, you're taking, and that number that it's centered around, you're going to take that away from the actual. The actual is the thing you don't know. You don't know what the bottle actually weighs. So you take that number you're centered on away from the actual, and then that's going to talk about the distance that's left. That's okay for them. Saying here they're talking about the distance being less than 0.6 or equal to.